The first step of designing an experiment is deciding what you want to know. One way to do this is to make an observation of a phenomenon in the world. An observation comes from what you see, hear, read, or experience. For example, perhaps many black and white mosquitoes at a local park bite you, and you know from megabytes that they are Aedes mosquitoes, container mosquitoes. You notice that trees border one edge of the park, while the other is next to an open grassy field. This observation leads you to wonder about where mosquitoes lay their eggs, because you can use that information to help control them and/or avoid them.
After you make an observation, you may wonder, be curious, or have an idea about something. From this wondering, curiosity, or ideation, you are in a position to be able to ask a question. Identify a question that you can answer. Does it have a clear answer? Does it have a dependent and independent variable? Does it have a measurable and objective answer? If yes, then it's a good question.
One way of constructing an especially good question is to consider what your hypothesis in your question is and how that can help you to test your actual hypothesis. Think to yourself, what can you do to answer the question? What can you compare to answer the question? So maybe when we go back to that example that we had about mosquitoes laying their eggs on one side of the park and not the other side, we can ask the question, do 80 mosquitoes oviposit more eggs in a grass field or along a tree line? That's a good question because you can count and compare eggs at each area of the park.
Next, you need to think of a statement that is an answer to that question. This would be your null hypothesis. In our example, the null hypothesis could be that Aedes mosquitoes, which are the black and white mosquitoes, oviposit or lay eggs the same amount in grass fields as they do in tree lines. So they're going to be about the same. Then you can write out an additional answer, and this would serve as your alternate hypothesis, which for the example would be Aedes mosquitoes oviposit or lay eggs different amounts in grass fields and tree lines. Note, you can also say that Aedes mosquitoes deposit more eggs near the tree lines than grass fields, or vice versa. You just have to know what you're comparing and what your results should, as you predict, look like.
Now it is time to make a plan for your investigation. What are you going to do to answer the questions? And what do you need to answer the questions? Think. Where will you do it? When will you do it? How will you do it? What will you record? What will you compare?
In our example, we are going to put equal numbers of ovitraps in the grass field and along the tree lines, spaced equal distance apart. We will use the same water, egg paper, cup size. Basically, the only thing that will be different is what we are studying: location.
Once you perform the investigation, what results do you expect to get? What do you think you will get? What will you compare to get your results? If your null hypothesis is right, what will you get? We would get a similar number of eggs in our ovitrap locations by the field and by the tree line. But if your alternate hypothesis had evidence in support of it, what would you get? We would get a different number of eggs in our ovitrap locations by the field and tree line. So the difference being a different number relative to a similar number.
Finally, the time is here. Carry out the investigation. Be sure to write down everything during your experiment. Those notes might help you explain your results. When you're done, write it up and share it with others. Good luck.